Okay, so welcome to lesson 2. What I'd like you to do, please, is to go ahead and make a new folder in your tile game folder. So you should have a tile game folder, and we have lesson 1. And what you can do is simply copy it and then paste it just using right click and change the name to lesson 2. This way you'll be able to go to lesson 1 and do something with what we left off there. We're going to be doing lots of code changes as we go through the different lessons, and we will want to be able to go back in time if you want to say, oh, I'd like to do this instead of what we did in lesson, say, 4. I'd like to go back to lesson 3 because that could be a good jumping off point for one of your games that you want to make. So this way we keep a history. All right. And then what I want to do is for today's activity, I want to create a sprite that we can control in our tile game. So we're going to open up Thawny and we will make a new module. Okay, as you see, I've got Thawny open here. And I'm going to open. I want to be really careful to just open the files from lesson 2. So go back to a folder and open up the files from lesson 2. And we want to open both of them so that I've got everything ready to go. So here's my settings and my main that we made in lesson 1 that's been copied over. We're going to make a new module today, and this is going to be called sprites. So we'll save as. Make sure you save in lesson 2 and call it sprites. And this module is going to store all of our classes for our sprites. So this is going to be a very long module. First, we'll need to import our Pygame. And we're going to import all of our settings as well. So we'll say from settings, import star, so I don't have to say settings dot every time. All right, so this is going to be our player class. And our player class is going to be a subclass of the sprite class from Pygame. And the main advantage to subclassing sprite. Now, sprite doesn't have a lot in it. It's really more of like kind of an organizational class, but it's got one key component, is that it allows us to put our sprites into a group. And that's going to be really important for us. Okay? And we're going to define an initializer. So the init, which is also called the constructor, has a reference to self, like all methods in a class do. And we're going to keep a reference to the game. And the game is actually a reference to our application class. And that's going to allow us to have access to every method we write in our application class through game. And this is a very important step here. We got to call the super constructor from the sprite class. If you ever get an error that says something like you cannot join this group or you're missing this method and it's in like the group class, you don't know what it is, it's probably because you didn't make it a sprite by calling the super initializer. All right, so we're going to make some comments here. We're going to keep a reference to our main.application. This is going to be important for us. So self.game equals game. Just something to point out. You'll notice that my self became italics, just like the word game became italics. The reason for that is on my options, I have on Thawny, I have that I highlight local variables. And I think that that's really helpful for me. It tells me that, for example, game is local. That means it only exists inside this method. And so does the word self. And that's a reminder I need to make it in every method. But you'll notice self.game, the game part is not. So it's just a nice formatting strategy, and it kind of helps make the self, I don't know, it almost kind of disappears in my view. So I don't get confused by it. I know that that's just my normal reference to my object. All right, well, there's a reference to our game. next what we're going to do is we're going to create an image. And we're going to make an image for this later. We'll use some images in this project. But for now, let's just make it a rectangle. And we're going to make it the size of a tile. So we're going to we're going to create an image surface of tile size, and we'll fill red. So let's see how we do that. I'm going to call it self.image because self.image is what is used to draw the image when we paint all our sprites. So we need to have that. But I can store into it any image I want. I can load an image or I can draw an image. And that's what we're going to do. We're going to draw an image by just making a surface. And the surface is going to be the size of the tile that we are using from our settings. Notice it is a tuple. Remember, tuples are like a list. Just for a reminder, I want to show you like that. I'll say T for tuple, 157. And let's do LST for list, 157. So same numbers. I want to show you that they behave the same when I call them. Okay? But while I can change the list, I can change what's stored in 1 from a 5 to a 9. I can also append to a list. And I can remove from a list. So let me show you there. It's got a 10 on it. And remove from it. I cannot do that kind of thing with a tuple. Let's do the same thing. Let's try and change the element in index 1, which is the second element, to a 9. You'll see we get an error. So tuples are very good for storing things. They don't have a lot you can do with them. But with the disadvantage to a list is that all that cool stuff you can do with a list, well, it takes memory. It has size. It has to have all those methods stored in it. So we'll see quite often that we use a tuple when we're trying to describe something that's not going to change throughout our application. So that's just kind of a review of the difference between a tuple and a list, and that's what we put in there. Now let's go ahead and fill it with red. So I'm going to take the image and just fill. So all surfaces have this fill method, and we're just going to say red. And if we go to our settings, we can see that we do have red as a color. All right. All right, the next thing I'm going to do is I'm going to create a rectangle. And this is really important because all of our movement and positioning on the screen will be done through a rect object. And we need to have a member variable called self.rect in order to do this. So we'll say self.image, and all surfaces, which the image is, have the method getRect, which just simply will return a rectangle Pygame object with the size of our surface, which in this case is a tile size by a tile size. Okay, next we'll do self.rect.x, and we're going to set that to our x position that we were passed as a parameter. But that x position is going to just be X number of pixels. I want it to be in the X tile position. And I do that by simply multiplying it by tile size. And I'll do the same with the Y. All right. And we're going to do lots of different ways to store position. But I'm just going to store the X and Y that I was given. Otherwise I don't have it. Whether we end up using it or not, it's good to have it. So self.rect.x is going to keep track of our tile position, but I want to keep track of the Y and X as well. So I'll make a separate instance variable or member variable X and Y. Okay? And the last thing we're going to do is we're going to add to the sprite group. Now, we don't have a sprite group yet, so we're going to have to let's go and make that first. I'm going to check my settings, make sure that I'm still using this. Looks like I changed this in our last video to explore different tile sizes. I want to go back to 32 pixels for now. So I'm going to go ahead and do that. And I want to say that I used 25 and 10. Let me go back and check. No, I didn't. I used 32 and 20. Okay. I can always change that easily though in my settings if it's too big or too small. All right, so we've got that. Now what we need to do is go to our main and we need to create a sprite group. The sprite group is going to be what it keeps track of all the sprites in the game so that we can easily update them and draw them to the screen. So let's make a sprite group. And this is going to be, sometimes you'll see people call this all sprites, but we want a sprite group for all the sprites. We'll also make some other groups as well that will work on just certain types of sprites. So pygame.sprite.group is the name of this class. So remember, if it's a capital letter, it's a class, and classes are like factories that stamp out objects. So it's creating a sprite group for us, which is initially empty. All right, so now that we've got that sprite group, let's go ahead and now we know the name is called sprite group. Let's go back and add it. So sprite group is contained in our main class, which is our main module, which within the class application. But remember, we kept a reference to our application in self.game. So I can access any variable from my application class that's in main through that game variable. So self.game.screen would give me my screen, self.game.running, even if I wanted to stop the game running, and also self.game.sprite group. So I have self, because we always in that, dot game, and the dot game is referencing this word self here because the self is this application. So self.game.sprite group. And I'm going to add to this sprite group. Well, what am I going to add? Let's think about that. I need to add the player. So what I'm going to be adding is myself. And a lot of students, as they're learning object-oriented programming with Python, get really confused with this use of the word self. Just remember that self is exactly what it sounds like, yourself. We are programming a sprite, a player, for how that player will behave. So I picture an actual player in my mind, and when that line of code is done, I picture that player going and signing himself up on a list of the sprite group. So we're adding our sprite group to we're adding our sprite to the game sprite group that we kept a reference to. All right. Very good. Now, what we want to do is we want to be able to move our player, right? And there's lots of ways to handle movement, and we're going to be changing it in different lessons, looking at different ways and comparing the benefits and costs of each one. You know, obviously, the more coding, the more stuff you can do. But we're going to start with a simple one. I'm going to write a method called move that simply takes a dx value. So remember, dx means the change in the x. So I'm going to set it to 0 and dx and dy to 0. I'm doing that to make it a little bit less typing later on. So remember, Python allows us to make default parameters. So dx, we can send a dx value, or we can just take the default 0. So in general, when you call move, the dx and dy, the move in those is 0. And what we're simply going to do is change our x by dx times what's called player speed. And we want to have a player speed variable so we know how to easily adjust our game if it's moving too fast. And then we're going to take our y and we're going to adjust it by the dy, again, times the player speed. Oh, I see I said play speed. This needs to be player. Please make that adjustment. So we need player speed in our settings. So we'll hop over to settings, and we're going to create a new section here. We're going to call this player settings. And our first one is the player speed. And I've played around with this and came up with one that worked well. And that was 0.4. All right, and we can adjust that and see how that works as well. Okay, so now back to the sprite. All right, so that's going to move our X and Y position, but notice that didn't move our rectangle. Well, we're going to leave that in the update method. The update method will be called once in between every frame draw. So it just takes self, and we're just going to position the sprite on the nearest tile space, okay? So check out how we do that. We need to position the recs X and Y. By review, the X and Y of our rectangle is the upper left-hand corner. So if it was the screen here, it would be this TH in the upper left-hand corner of my whole screen. That's where I'm positioning that. Later on, we'll look at different ways, like we can set the center of the sprite, the right, the left, the bottom, whatever we want. But this is the upper left by default. All right, so what I'm going to do is I'm going to use the method int. It's actually technically a function. So the int function on my self.x. So since we're moving at a player speed of like 0.04, we're oftentimes going to be at an x position of say 19.2 or something like that. By inting it, I'm simply going to be dropping the decimal points. It's not rounding, it's dropping off that last decimal, like 8.9 would just be an 8. And then we need to position on the screen, which is at our tile size. So just like we did before when we positioned it with multiplying by tile size, we'll do that here. And now I will int the y and multiply by the tile size. Okay. And that's it for now on our player sprite. Let's hop over to our main and let's add one to our application. All right, so in our initializer, we have this sprite group. Well, it's time to make a player now. So we'll just call it self.player. And it's going to be in sprites.player is the name of the class, which takes a self. And let's position it at tile 1010 for now. Now, this is not going to work, though, until we add it to our imports. So we need to import sprites. I went ahead and left it as sprites.player. I think that's fine. If you prefer to be able to import by just saying, if you prefer to be able to just say player, then you'll need to say, you could say from sprites import star, but that can cause some problems. Instead, I would just import like that. So if you do that, you can say just player, but I'm going to leave it as sprites.player so it's clear where the player class is located, that it's located in the sprites module. So if you just import it like that, you have to say the name of the module dot the name of the class. All right, let's check out our game loop. Currently, the only thing our game loop can handle is it can handle quitting. Well, let's add some more events. We're going to add a couple more things, though. First thing we're going to do is handle our frame rate. So we're going to make it to where we have a 30 frame rate right now. We'll look at 60 later. And I'm going to create a keymap. So a map is a linking of one thing to another, what's called a key and a value. So we're linking the key up to the value false. We're linking the key down also to the value false. Left gets linked to false, and right to false. So notice that when you make a map that you start with a curly brace, a little curly bracket if you want to call it, and we can use anything for our key, but I'm using strings up, down, left, and right. Let's review what a map looks like right quick in our interactive shell. So I'll just call it M for map, and I'll say A goes to 1, B goes to 2, and C goes to 3. So now, just like with the list and tuples, we're going to access something in these square brackets, but instead of the index, we're going to put the letter A. And you'll notice that it brings up the 1 because that's the lookup key that allows us to quickly look up and find something. I'm free to change a value. If I want to change A, I just simply do that. And you'll notice that the value of A is changed. I'm also free to add a value. Say we don't have a D yet. We can add that, and we'll make it, how about 9? And so now I've got, excellent hitter. I've got that stored. So that's pretty much the way it goes. And that's what we're going to be using. So when a key is pressed, we'll be able to change the key map values from false to true. So note how we do that. All right, currently, again, like we said, we're only handling the event type quit. Let's take a look at some other event types. We could have a Pygame event key down. And if we do have a key down event, then we're going to let our handle key down method take care of that for us. I'll send it the event. The event, each event type has different member variables. The key down events, so if you have an event and that event is of type key down, it has variables representing what key was pressed, which I hope makes sense. So I'm going to send our event and our key map. Elif, again, which means else if the previous one was not correct and this is correct, we're going to handle the key up. So it's a different event for when the user presses down a key than when they release a key. And so we'll say self.handle key up. And again, we're going to need to write these methods. They don't exist yet. And we'll send it the key map as well. So let's handle that. And I could have done it in here, but it's time we start breaking this apart. I'm eventually going to move the event somewhere else as well. I don't want one particular method to have too much in it because it becomes difficult to read. I want to be able to read my game loop as a series of steps, not a long list of code that takes time to read and understand. All right, so let's do the handle key down. And that needs a reference to itself, which is when we say self.keyDown, that word self goes right there. Then it needs something to store the event we send it and the key map we send it. And I can just use the same words, but I could also change these variable names. Whether I change them or not, this event is going, when I do key down, this event is going to be stored there and this key map is going to be stored there. All right, so we're just going to use some if statements. So if event.key, remember we're only here if it's a key down event, so it has a key associated with it, is the key up. And that's how we say it. These are constants in the Pygame module. So it's just Pygame k underscore up. So if the up key is pressed, we're going to say key map up gets assigned true. So now the up key is set to true. Elif event.key equals the pygame.key down, then we'll set the down in our map to true. And we'll do the left. and the right. And that's it for the handle key down. It just affects our map. Let's do the key up. Well, when they press the key up, then what used to be true is no longer true. And I'm just going to kind of copy and paste this because it's almost exactly the same code. But if we... That's not right. But this time, if the event key is up, that means they've released that key, so we need to make them false. And there we have it. All right, let's go back to our game loop. And after we've processed each event, I would like to move our player. So we'll do that before we update our screen. And the way we're going to do that is with self.handleMovement. And we'll handle the movement by sending it a copy of our keymap. Note that I could have made our keymap a global variable by putting self here, or at least global is probably not the right word, but an instance variable. If I put the word self in front of it, then I can access it in any method without having to send it. But I wanted to keep it local, mainly just to discuss local variables. By keeping it local, I have to send it as an argument, or else I won't have access to it. And either way is fine. So then I'll say, well, I tell you what, we need to write that method before I do that. So let's write the handle movement method. We've already got key down and key up. It's time to handle the movement. And all it took was self and a keymap. And basically, we're just going to move the player based on what information is in it. So if the keymap dot left is true, and we could say equals true, but because keymap values are either true or false, I can just say that if keymap left, and I think that's a little more readable than saying equals true. Then self.player.move, remember the name of our method was move, and also remember that our move method has default values for dx and dy, so I don't have to tell it how to move dy because I'm only moving left. The only thing that should change is dx, and we'll just put a -1 so that it knows to move 1 to the left times our player speed. And I can do elif, or no, you know what, we'll do if. This, by doing all ifs, that's going to allow us to move diagonally. So we can actually move in more than one direction instead of doing elif, which would only allow us to move in cardinal directions. We'll look at both though. So if it's right, then dx is a +1. If we have up set to true, because the up key is pressed, then we're going to move the dy. But it's a -1 because up is in a negative direction in the traditional formatting there. And we'll look at down. There we go. And I want to say that's really about it. So let's try running it. Okay, we're not quite ready yet. I got one thing missing. I called self.clock.tick, but I never actually made my clock. So let's make our clock. Our clock will be a pygame.time.clock object. There we go. And we'll look and see if we have any other errors to look at. Okay. Oh, we're not painting to the screen right now. Our arrows seem to work almost okay. We got missing player speeds. We got to go fix that. All right, press the stop. So player speed is not defined. Let's go to settings. We got player speed right there. Let's make sure our sprites are importing settings. Yeah, they are. Oh, you know what? This is the wrong settings. I need to save as and make this lesson 2. I got the wrong settings, so it's looking at the wrong file. Okay. Run that again. We're still not painting to the screen yet, though, so we don't see any changes. But up, down, left, right has no attribute down. Okay. Oh. This should be the word move. I got kind of ahead of myself. Trying to talk and code is always difficult for me. All right, now we just need to paint it. Looks like everything's working okay. No errors. We just need to be painting our player to the screen. So let's do that. So in our game loop, we have a moment where we fill the screen. We show the tile grid. And it's time to update all of our sprites. We haven't done that yet. So we will update all sprite positions. So it's going to call all of the sprites update methods that we write. So self.spriteGroup.update. After we've done that, it's time to draw them all to the screen. So self.spriteGroup.draw. And what do we want to draw them on? We don't have to draw them on the screen. We could draw them on an image, but we'll draw them on our self.screen. You just need to pass the draw method a from the sprite group. You need to pass it a surface to draw on. And then lastly, we flip the screen so that we can see it. And let's try that. There is our player, and as you can see, it does move across the screen one tile at a time. And that you can see how this would be fairly useful. We can move diagonally in that kind of zigzaggedy kind of way. If you don't want to move diagonally, then we can go here to our handle movement, and just simply doing an elif is going to change that. But the problem with elif is now left gets priority. So if you are, we can't move diagonally, and whatever it is that came first is going to get priority. So left and right come before up and down. So if I have up and right pressed, even if I'm pressing up first and then press left, left is going to get priority. And this is allowing me only to move in 4 cardinal directions. So we'll do that. This looks like some pretty fast movement. Let's check our settings and see if we can't change that. Let's try player speed, maybe 0.3. So not quite half, but as slow. Okay, I like that. Okay, next thing I want to do is I want to change the title because this is no longer lesson 1. This is lesson 2. And I think we're pretty much done with this lesson. We've got everything the way we want. Okay. We're good to go.